Okay, and we have discussed the steps which you need to take starting from your education, then the steps after studies, basically for specializations, and then some of the tasks which engineers do. Okay, then we cover different types of engineers. Okay, you find many of them here. Then we ended up with this activity where you have to think about products or works which are done by three types of engineers, and you had to post it in the blackboard. Okay, now we go towards an important aspect of engineering, or an important aspect of profession. Okay, any profession. How to solve a problem during your career, during your studies. You are faced with many problems. So once you are faced with problems, you can get into panic. Okay, what to do, and you lose heart. You don't know how to deal with it, how to tackle it. Okay, and sometimes uh, you are stuck with something, and it is affecting the other things which you are good at. Okay, so I have seen students who do bad in one exam. Okay, in the subject in which they were good, just because something else happened with some other course. Okay, there was a assignment, there was a project. Okay, something happened at home, whatever. Okay, and the course in which they were supposed to get A, they end up getting B in that course. Okay, not because of that course itself, but because of the problem which they had elsewhere. Okay, so the point being, if you know, if you have a process of handling the problem, it will affect you less. Okay, first of all, understand this one, that you cannot avoid problems in life, you cannot avoid problems in your career. Okay, so you have to be mentally tough and strong, and you have to be flexible and adaptive to difficult situations. Okay, many times just because something is new, you become nervous, you become stressed. Okay, and that itself creates a new problem. Okay, because you cannot handle the situation. Okay, that new situation looks like a problem to you. So you are very comfortable with how you are dealing with life, how you are dealing with your colleagues, how you are dealing with your career. uh, a very common example, making groups in your projects. Okay, I always make group with this guy, I always make group with this girl. Okay, and then we are soulmates, huh? we are we will never make group with anybody else. Okay, so this is so if somehow you are forced to work with somebody else, even though that somebody else is a very good student, he is very helping, very supportive, he is carrying most of the burden of the project, but to you he looks like a problem, or she looks like a problem. Okay, just because something has changed. So going back to the point, sometimes problems are there, sometimes you create problems, but in both cases, if you know how to deal with it, if you know how to handle it, then you will get through it. Okay, so this is something you cannot avoid. Okay, so you need to train yourself, you need to understand how to deal with it. Now in engineering, uh, we are all about analysis and calculations, right? This is our core. Okay, our core is what? Analysis and calculations and mathematics. Okay, this is our core. So we need to deal with the problems using our own strength. Okay, you need to deal with the problem using your own strength as an engineer. Okay, and your engineer, your core, your strength is your analytical skills. Okay, we are good at following the procedures, we are good at following the methods, the design codes. Okay, the design methods, the equations. Okay, and so on and so forth. So we need to use it in managing our problems as well. Okay, so this is a process which you can go through when you are dealing with your problems. So first step is you define the problem. What is the problem? And this is where you can differentiate. Is the problem really a problem, or is just that I am getting stressed because it is something new? Okay. And in some cases it may not even concern you. It's not a problem. Okay. So somebody else in your office is doing something, okay, and that is damaging their project, but it's nothing to you. So when you get to this stage, you define problem, you will understand that it's not my problem. Okay. So and then you will see, do I need to really solve it or not? Okay. Does this problem require something from me? Okay. Do I really need to do something about it? And it goes back to the construction projects as well. It goes back to the civil engineering projects as well. We have said it a number of times. Civil engineering or engineering is about solving problems of the community. Okay. We are doing things, we are constructing things because they are supposed to serve a purpose. They are supposed to do something for the community. So if you do not define the problem properly, your solution will go to waste. Okay. So first you need to define the problem. Okay. So that you know what type of solution can work. Okay. So when you define the problem, you will look at what is needed by the community, by your client. Okay. What will be the possible solution, and what is the goal you want to achieve in the end? Okay. When you define the problem, you know that I need to solve this problem, this is my goal. Okay. The problem is, okay, we have too much environmental emissions, so the goal is to reduce the environmental emissions. Okay. The problem is we have we don't have a proper road, or there's too much traffic congestion, or the water is not clean. Okay. So the goal is to have clean water. Okay. Or to reduce traffic jams. Okay. So when you define the problem, your goal comes up. Okay. The end goal, the outcome of the project comes up. Okay. Then you start gathering more information. So okay, what I need to solve, then what are the relevant things which I will need, and you start gathering data about those things. So it's a bit of a research. Okay. And now we have more tools available for the research. Right now you can simply ask, you type, or you just, even verbal questions are accepted as well in some of these tools, the AI tools. So the research becomes very you know very easy. So you get the relevant data. Okay. What other solutions people have already done? So first of all, you gather data about the problem you have. Okay, we have traffic jam, for example. Okay. Or we have environmental emissions. Yes. But how much? We have too much. Okay. What is too much? Okay. Until you have this data, your goal cannot be definite. Okay. And then you are not sure about your success. Once you finish your project, once you finish your providing your solution, you are not sure about your success because you didn't have the data to compare with. Okay. So we have accidents on the highways, we have traffic jams, we have water quality problems, we have air quality problems, we have housing problems. Okay. But what is the extent of this problem? Okay. So you gather data about the problem itself as well. Okay. You identify, anybody can identify the problem, right? It takes very little. Okay. So I can read a paragraph and I can tell you, okay, this paragraph has mistakes. Okay, fine. How many of them? Are they all related to grammar, or there are spelling mistakes? And okay. So if I don't tell you this, then it will be very difficult for you to correct yourself. If I don't give you more details, okay, how many mistakes, where are those mistakes? Okay. And what type of mistakes you have, you cannot correct yourself. Okay, this paragraph or this essay or this assignment has mistakes. Okay, so what should I do? Nothing. You cannot do anything until I give you more information. Same thing happens in civil engineering projects. Okay, we have bad water quality, but how bad is it? Okay, what are the pollutant levels? Okay, and then you look for, so this is about existing data, and then you look for existing solutions. Okay, you don't need to reinvent the wheel every time. You don't need to start from scratch every time. People have done or dealt with these types of problems before you. Okay, so you can learn from it. Yeah, you can see if those solutions are applicable or not. One thing, you when you are looking at different solutions at different in different uh, previous cases, you need to keep in mind your own case as well. So something which worked in Canada may not work in Bahrain because the weather is different, the people are different, okay, the soil is different, okay, so many different things. Yes, you can still look what they have done, what were the results, okay, but before you say, okay, this was the best solution, I should do it, before you get to that decision, you need to look at the differences as well. Maybe that thing can work, maybe some things are there are some solutions which are very robust, okay, some solutions which are very generic, you can apply them anywhere, okay, but there are others which are not like this, okay. So but the point is, before you go on and take decision, so you get very excited that, oh, I found a solution which has worked at all the previous cases, but your case is different than all of them, or maybe the situation has changed. The same solution has been applied in 100 different places in Bahrain, it worked there, but now situation has changed, your soil is different, uh, the weather has changed, okay, your client doesn't have that much money, okay. So you look at existing solutions, you look at their applicability to your situation as well, okay. And this brings to the next point. For each solution you look for requirements. If I want to, so you establish that, okay, I will do this type of treatment system, it has worked everywhere and it does not get affected because of the weather, okay, so I can apply it even in Bahrain as well, okay. Okay, I want to do it, but what are the requirements for constructing this type of a treatment system? Maybe the requirements are such materials which you don't have available. So one solution which was very cheap in US or very cheap in Pakistan can become very, very expensive in Bahrain. Okay. So this is another aspect you have to look at. First aspect was applicability. Second aspect was what are the requirements. Okay. Okay. This is all data gathering. We haven't reached a solution yet. We gathered data about our own problem, what type of problem we have, what are the solutions which are already available, which are already applied in such situations, and what are the requirements for applying these solutions or for applying any solution in general. I know for construction I need material, I need labor, I need equipment. So there are some things which are general. I know that I will need them. Okay, money for example, big requirement. So there are some general requirements, and there are requirements which you will identify from the previous solutions. So this is all data gathering. Okay, now I have many files, folders, okay, lots of data available, okay, Excel sheets and graphs and whatnot. Now you sit down and you start preparing solutions for your problem. Okay, so you look at, okay, if I have this much issue, which of the solutions have worked? If I try to work it, if I try to apply it in my circumstances, how much cost I will need, how much time I will need. Is it really feasible? Feasible in simple words means, is it really possible? Okay, or is it, to be more exact, is it really practical to do that? Okay, yes, I can go for this solution as well, but my cost will be 20 times higher. Okay, so it is possible, but it's not feasible. Okay, so feasible is something which is practical and possible both. Okay, like which can suit, which suits you. Okay, which suits you. So now this is the third stage where you start preparing uh, now specific solutions. Okay, even from some of them can be from the past projects, or maybe you are thinking something new from your own mind, from your own experience. Okay, you develop something new, or you look at what others have done in one of any of these cases. But in this case, you are basically generating as many possible solutions for your problem. So until now, I was looking at the data only. Now I am generating something on my own. Okay, and you will agree that for one problem I can have multiple solutions. Okay, I can have multiple solutions for one problem. So we can have uh, multiple solutions for traffic jam. We can have different types of buildings. We can have different types of water treatment systems. Okay, and so on and so forth. So, and all of them will have their cost, all of them will have their time, duration, okay, and so on and so forth. So in the brainstorm and plan step, you are looking at all possible solutions. Okay. Uh, the term brainstorm here means that we are looking at all possibilities. Okay, so I am not limiting myself to one. Okay, so whichever is the one, I will take it. Or I will only talk about first three or first two. No. Okay, brainstorm, whenever we use the term brainstorm, it means that everything included. Okay, everything which is possible will be included here. Okay, but now it is not about previous data, it is about your own project now. Okay, your own problem. Then you have multiple solutions, all of them are possible, all of them are related to your problem, your project directly. So now you evaluate between them. For all of them, you have calculated cost and time, two very basic, very important parameters. So you can evaluate on the basis of that. If I take solution A, I will have more cost, but I will finish early, and so on and so forth. You can have a solution which costs less and finishes early as well. Okay, so this is where you select the best solution, and then you prepare a detailed design for it. So in the brainstorm and planning stage, because we are dealing with multiple solutions at the same time, we don't go into too much details. Okay, if we just uh, take approximate values. Okay, so we have a sketch, but we don't have the detailed drawings and specifications. Okay, so from that sketch or from that idea, I approximate or I estimate the cost and time. Okay, but once I selected the best one, then for that best one I will you know do more work. Okay, prepare a detailed design and so on. So selection happens first, then the design. Selection happens first in the design. When the design, you will use softwares, you will prepare drawings and documents and whatnot, and you may hire someone, a specialist as well, who can prepare the detailed design for you. Okay, so this is the design stage. Then you go and build or implement your solution. Okay, your design. So this is the field work now. This is in our case construction work. Okay, if you are mechanical engineer, then it will be the production in the factory or something. Okay, so you do the building or implementation stage. Okay, so you did the design, now you are going on to the implementation stage. Okay, your work doesn't end here. Okay, you may say I developed the design and I implemented. What else is there? No. Your design is going to be implemented in the real world, and real world is not under our control. Okay, and first of all, the first thing is your design may not be as per your product, your final project may not be as per your design. First thing, so you need to check if the person who was implementing the design did he do a proper job with your design or not, okay, in the field. Okay, so we need testing for that as well. Secondly, your design may not be uh, performing as per your expectation. So you thought that if I apply this treatment, then the water pollution level will go up to this level. So now you need to check, is it really happening? Okay. Same thing with traffic congestion. We were trying to solve traffic congestion problem, but now we are having too many accidents. Okay, people are over speeding, something like this. Okay, you prepared the best design of the building, but now somebody told you that we are having cracks in the walls and the beams and whatnot. Okay, so now you need to test and you need to check what went wrong. Okay, first of all, you need to test if the implementation is according to design. Second thing you need to check is the design is really as per your expectation. So there are two important things which you need to check. Okay, once you have done that, you will find, obviously you may find problems in implementation, you may find problems in performance. Okay, so now this is the time when you can learn from your mistakes. Okay, this is a time when you will learn from your mistakes. So in the future projects, you can even do better than that. Okay, you can even do better than that. Okay, then everything should be documented. Okay, and it does not start from here, it actually starts from the first step. So this thing, these steps which you see here, test and iterate, document, communicate, these are parallel steps which are happening with these ones as well. Okay, so these are parallel steps. You don't wait till the full project is done before you start doing any testing. You test during the implementation. So if you can identify a mistake, you can detect an error during the implementation, you will correct it before the project is finalized, before the project is finished. Okay, so testing and iteration, it happens during the implementation as well, and it happens after it as well, because you need to check how the project is really performing. Same thing with documentation. Okay, so starting from the definition of the problem till the design and testing and iteration, all these things are documented. Okay, and this is the whole idea behind the learning phase, right? If I don't document these things, then how would I learn from them? How will I improve myself? Okay, I have it in my mind, this happened, but I don't, after a few days, few months, I will forget about it. Or even if I don't forget about it, I don't have the values. I will definitely not remember the values. Okay, so I document all these things. So I can exactly, when I go in the future, I can exactly look at the values and give specific ideas on how to improve myself. Okay. Secondly, documentation is also important because you can see all these steps are connected. If the problem, the definition of the problem is required for the data gathering. If I don't know what the problem is, I cannot gather the data. Okay, the type of data I have will affect the solutions, the different solutions I'm making. From these solutions, I will pick one of them for the design, and from the design, I will go to the implementation stage. So all these steps are connected. So I will need the documented proof of the problem to start my gathering of information. I need this information documented to brainstorm my solutions. I need those multiple solutions to select one of them. Then I need that selected one with full design to start the implementation. So document from one stage goes to the next stage. Okay, and this brings to the same thing with testing and iteration as well. You need the documented tests. Okay, and whatever changes you have made, you need it documented to properly learn from it, okay, for future and to implement any changes in the same project as well. So in the construction projects, they have something which we call as change order. Okay, so what is the change order? This is a document which people on the project need to fill if they want any change in the ongoing project, in the same project, in the middle of the project. And these change orders at some level are very common. Like there are obviously changes which are of a small nature and changes which are very big. Okay, but almost all construction projects have small changes in them. So they regularly, you know, implement the testing and iteration. On the basis of that, they make changes. Okay, and even the changes are documented. Okay, because you don't want to get to the end of the project and the client comes and he says, oh, I told you to use this material, but you use this material. You say, oh yeah, we changed. Why did you change? Then you start explaining. Okay, and the client may not trust you. Okay, you should have documented it. You should have taken the approval on the same document from the client, from the consultant before you implemented the change. Okay, so changes for the same project are also important. They are documented because in many cases when the change does not happen properly, the person can take you to the court. Okay, they can fine you for thousands of BDs because you did not go according to the plan. Okay, and can happen both ways. The client may do it, the contractor may do it. The contractor may say that he is asking me to do something without approving it, okay, without the necessary documentation. Okay, or the consultant asking me to do it which is not in the plan. Okay, so the documentation helps with all these problems. Documentation of the testing and iteration and so on. Okay, this brings to the next point. You are keeping the documents, but the documents should be prepared after consultation of the relevant parties. So when I'm defining the problem, okay, I have to deal with the client. Who will define the problem? The client. Okay, if the client comes to me and he tells me something, and then I say, okay, you go and I will think about it, then I may assume things which the client may not like or the client may not want. Okay, so in the whole definition of the problem phase, the client must be involved. Okay, so first level of communication with the client. Second, when you are gathering the data, you're gathering data about what? You're gathering data about past projects. You're gathering data about the problem itself. Okay, so again, who are the relevant parties? Maybe the other engineers who have worked on similar projects, you can get data from them. People, the government ministries who are gathering data about pollution and traffic and accidents and housing and population, and so you need to communicate with these parties. Okay, requirements, who will tell you about the requirements? The people who are in the market. Okay, I want to build this sort of a building. Okay, so from where will I get the material? What is the cost of the material? And so on and so forth. Okay, then the brainstorming session. Okay, again you need the client to be with you. How would you know that this solution is possible and this one is not possible? Okay, the client may reject some of the solutions from the start, so you will save yourself from working on them. Okay, you may tell the client, okay, instead of building, build villas, 100 villas instead of 20-story building. The client will say, no, this is not possible for me. Okay, so the client should be there brainstorming. Then you cannot brainstorm the whole all the solutions yourself. You need your own team with you who will work with you later on. Okay, so it's not a one-man job that I'm sitting in my office and I'm brainstorming about different solutions. No, obviously when one person is thinking, some of you send me the project reports, right? Before you submit the project report, some of you send it to me. Okay, so I see things which you don't see. Okay, am I getting the grades or you are getting the grades? You are getting the grades, obviously. And the person who is sending me the report in advance and they are preparing the report in advance, I believe they are very serious about the grades. So they don't want to make mistakes by themselves. But when I look at it, I may find like 10-15 mistakes in that. Okay, so does it mean that the other person was trying to make mistakes? He was ignoring the things? No, Just so looking at the things from somebody else's eye, from somebody else's perspective is really helpful. Okay, my PhD supervisor, he always used to say this. Okay, and again, something which can be beneficial for you. He used to tell me, once you have finished something, okay, before you send it, you just leave it for some time, come back, review it yourself. If you cannot let somebody else review it, no other person has time for you, or it's not something which somebody else can see, then at least you should review it after some time. Okay, so when you give a gap, so I was writing the report, now I give a gap, okay, maybe 2 hours, 3 hours, or next morning I come back and I see my own report. Okay, now I'm looking at it from a fresh eye, I'm looking at it from a fresh mind. Okay, so I may find things which I did not think about when I was doing it. Okay, he used to tell me that you are too involved in it. Okay, so you need to detach yourself from that thing so that you can see your own mistakes. When you are too involved in it, you don't see your mistakes. Okay, and this is what happens when somebody else is looking at your work. Okay, they are looking at it from a different perspective, they are looking at it from a different mindset. Okay, so they will find things which you cannot find, which you cannot see. Okay, so I was talking about brainstorming. Brainstorming is not done alone. Okay, I already gave the example of having a client with you. Okay, so you need to have other people with you as well, other experts, people who you know will be in your team during construction, during design, because they will give you their own perspectives. Okay, so there will be very low chance of you missing something important or you working on something which is totally useless. So again, communication is important at this stage as well. Then you go to the final stage, design. Again, design is not a one-man job. Once you finish you have to consult the government authorities, you have to take their approval. Again, you have to go back to the market, you have to see which things are available, you can only use them in your design. You have to get back to the client and you have to check with him if this final design is fulfilling the criteria set by the design. Does it really solve his or her problem? Okay, is it really how he wants? Sometimes the client rejects projects because they don't look good. Yes, it does everything, it's cheap, it will be finished fast, but I want something which is more good looking, which is more aesthetic. Okay, so again, communication, importance of communication. Then the most important stage, the implementation stage, right? No matter how good your design is, if your implementation is bad, everything goes bad. So communication is important, it's very, very important here. Okay, on a construction project, there are multiple parties involved. Okay, the client is obviously there, he has to, the government, he is providing the fund, he is the one who will approve the budget, and he was the one who will look at how much work is being done and so on and so forth. So his involvement is there. Then you have a big team, you have labor working on the site, you have a foreman, you have the supplier, you have the equipment operator, and every equipment has a different operator. So imagine how many people are there. So if you take one activity of concreting, okay, so there's a formwork supplier, then the labor who is fixing the formwork, then there is the concrete supplier, then there's the driver who is driving the concrete truck, the mixer. Okay, and all these people must work together in order for concreting to be successful. All these people at the same time, at the same place. Okay, so it's not like I will send them something and they will look at it and they will give me feedback. No, all of them must come together at the same time, at the same place. They all must know the requirements. If any of them misses the requirements of concreting, your concreting will not be successful. Okay, so the labor should know what they have to do, what are the requirements. The equipment operator must know, the concrete supplier must know, the foreman must know, the person who is supervising must know. Okay, and the person who is testing the concrete must know what are the requirements. Okay, so again, going back, the importance of communication. during implementation. I just gave you example of one activity. You can think about how many activities, how many times you have to do the concreting, and every concreting is different. Okay, same thing with the steel requirements as well. Okay, and so on and so forth. So then we have the testing and iteration. Okay, again I told you about change orders. Okay, so you cannot change things on your own. When something goes bad, you need to go back to your client and whoever it is, and you have to tell them this happened, I'm going to make this change. You have to take the approval. Without the approval, you can delay the project, you may get into legal cases and so on and so forth. So I have tried to explain the importance of communication, all the steps. Okay, and obviously documentation is a very important part of communication. Then we have the maintenance and optimization after the solution is implemented. Now you have to maintain. Okay, it's a very important field in engineering, especially in civil engineering. I told you earlier as well, buildings get constructed in 1 year or maybe in 6 months, but they stay in operation for 50-60 years. So construction happens for months, and the maintenance happens for decades. Okay, 6 months of construction, 60 or 6 decades of maintenance. Okay, and during maintenance you try to maintain the performance of the building. Maintenance is not that the building is, yeah, see, the building is still there, it's intact, it's not falling down. Okay, so we are maintaining it. No. Okay, the doors are not opening, there's no ventilation. Okay, people cannot walk safely. Okay, the air conditioning is not working, there's water leakage everywhere, people are slipping and so on. This is not maintenance. Okay, so maintenance is, yes, I need to keep the structure intact, and the other thing is the performance of the building should also remain functional. Okay, so the building should remain functional during the whole life. Okay, so maintenance has this aspect as well. So this is where the optimization comes. Optimization means you maintain something at the minimum level, at the appropriate level. Okay, the lighting, the ventilation, the heating, the aesthetic, the look, everything. Okay, that's why we do the paints, right? Why do we do paint and plaster on the walls? It does not affect even it may do some extra weight, it may put some extra weight on the building. Why do we do it? We do it because without that the building will not be functional. Okay, so to keep the performance at the optimum level, I need these things. Okay, this is the general process, but it can change according to different fields. A mechanical engineer may apply it differently than a civil engineer, and then an IT engineer, and so on and so forth. Okay, so now I will divide you into groups. Okay, and each group will